Welcome back. Thanks for joining us for another episode. We're going to be talking today about attack surface management, and this has come up pretty much in every course that I've done here so far. Managing your attack surface and a lot of times reducing it, making it as small as you possibly can while still staying productive.
Yeah, this is a big deal, and Microsoft gets so hammered for this, right? When you look at operating systems, you have the Mac OS, you have those engineers running Ubuntu desktop, and then you have Microsoft Windows. Microsoft Windows always gets such a hard time because there is potentially a massive attack surface. There's the built-in chat that Microsoft has got for you. There's all these services, DNS services, all these kinds of things that are baked into the operating system. And DNS was a terrible example because that's a critical service, but you get where I'm going. Microsoft adds all these great new features, and that can really expand that attack surface. But I want you in this episode to think beyond the workstation and think about the various attack surfaces that may exist in your IT infrastructure. And it's not just a reference to the endpoint operating systems. When you have a router on the perimeter of your network, that router has an attack surface. And just like a Microsoft Windows operating system, that router may have additional services and things installed that it doesn't really need. A classic one you see is the router is a DHCP server. And I will say to the IT engineer that's in charge of that router, why is it a DHCP server? And if they're being honest, they often look at me and go, oh, didn't even know it was one. I didn't realize that service was on by default. So those are the kinds of things that we do with attack surface management. And to formalize this discussion, we have some key points we want you to know. Number one, a lot of companies will go in and have to do a full discovery of what devices of theirs are exposed on the edge of the network. And let me just impress upon you, this is not for traditional private IT environments only. In fact, this gets huge on the cloud. What I've seen, Sophie, time and time again, is IT people will move to the cloud and they'll start standing stuff up there really quick, and then they don't even know what is exposed to the public. So we'll want to be very, very careful. And in fact, we may even engage in a passive discovery of the network using tools to figure out what is the attack surface that is exposed to the public. It can be that tricky to figure out. Jeez. Especially considering, Sophie, I just realized this, like a lot of networks, even our own here at ACI, they grow through merger and acquisition and expansion. So you can kind of lose track of, oh my gosh, what resources of ours are exposed on the internet.
You probably need to revisit that every time you've got a big change like that.
And Sophie, what makes this difficult and gives us job security, you'll be happy to know, is that, remember, a lot of those discovery tools, we harden the network against. So it's very tricky. You have to go in and you have to say, okay, allow this ping sweep to occur because of this work that we're doing. So you have to maybe take down the security control, do the ping sweep, then put the security control back up. So it can be fairly tricky to identify this. Now, once we figure out, Sophie, where the attack surface is, we should go in and test the security controls. Make sure you're protecting that visible attack surface as much as possible. Something else that we should do is consider offering bug bounties to people like Daniel Lowry to come in and find bugs that exist in that exposed stuff. And Sophie, I know you've taught a lot about this kind of content like bug bounties, but I was kind of stunned when I was researching bug bounties at one point in my career because I didn't think they were done by like high profile organizations. And then I discovered that like the Pentagon in 2018 did a bug bounty against their systems to a bunch of people. So it's a legitimate thing where, huge high profile companies will hire a team and they'll say, we'll pay you if you find bugs or flaws in our software. Pretty cool. The other thing that we do, as Sophie alluded to, almost always is we want to reduce the attack surface. So we are constantly looking at what we are exposing to unprotected areas of the infrastructure and reducing it, oftentimes disabling unneeded services, even completely uninstalling services. And I'm glad to report that from Microsoft to Cisco to Novell, I just went back about 40 years, to Juniper, okay, to Nortel, to HP, they're all starting to build modular operating systems where we can take entire chunks of the OS and remove it, and that's a great thing.
Oh, that's smart. So you're saying that's a pretty recent development?
Yeah, like Cisco for decades had a monolithic OS, and now throughout all of their equipment, they're going modular. Where, Sophie, you'd be able to go in, remember the DHCP example I gave you? You'd be able to go into the router and say, wait a minute, not only am I turning off DHCP on this router, but I'm removing that functionality completely. So now your attack surface is really well protected.
Yeah.
An attacker goes in, tries to enable your DHCP service, it doesn't even exist.
Yeah. So that would be one way, like you said, you gave that example of that DHCP, removing that service.
Yeah.
Are there any other like classic examples of reducing your attack surface?
There are. And by the way, just one more thing before we leave this, and I'm going to show Sophie a great example. In fact, it's going to bring back, I hope, some like memory bells for Sophie, because it's something that we taught long ago, but still, I hope Sophie remembers it. But before I do that, just remember, pen testing and adversary emulation, this is another place where you would engage in that. So Sophie would identify the attack surface of her cloud solution, for instance, and then she would call Daniel and I and say, okay, guys, here is my exposed attack surface. See if you can tamper with it. See if you can penetrate it, etc. So this is a great, great thing for pen testing. All right, now to Sophie's superb question. I'm going to take you out to a beautiful to a beautiful cloud service called Azure. And why we are in Azure is I wanted to demonstrate for all of you just how vendors are really starting to recognize these cybersecurity principles that we preach here at ACI. Watch this. In Azure, I'm going to go and look for a product called Intune. And Sophie and I did about a 20 episode, I think, course in Intune recently. And one of the things that's available here, let me blow this up so you can see it even better, is notice right here, there is a node called Endpoint Security. And if we go into Endpoint Security, what do we have in there? We have none other than attack surface reduction. So Microsoft recognizes, our operating system, which tries to do everything under the sun, gaming, family and whatever, right? Office work. Microsoft tries to make Windows 11 be everything to everyone. Well, they recognize in a corporate environment, you're probably going to want to go in and click through how to take your Windows 10 or Windows 11 or Windows Server and make it more secure by reducing the attack surface. Look at this. They take us through, which is very much like a wizard that we would create in order to go in and reduce the attack surface on the Windows system. So it's great to see vendors are giving us tools, giving us features in operating systems to reduce that attack surface. And as Sophie indicated in the very intro to this episode, that's a lot of the management. A lot of the times it's, okay, we know what our attack surface is. We don't need to discover it. We need to reduce it. Help us reduce that attack surface.
Well, an example you just gave was in the cloud with Azure. So it's also a cloud thing. I would imagine it probably is more of a concern in the cloud.
It is. You're exactly right. And like I said, Sophie, remember, watch out for this. A lot of people rush to the cloud without fully understanding it. so they don't know what's exposed. In AWS, when you are working in your initial virtual private cloud, that initial virtual private cloud that you're working with, the default VPC, it has an internet gateway attached to it, and it is a public thing. So I hate to do an ad for ACI Learning right now. Please don't turn off this episode. I'll keep it brief. In fact, I don't even care if you use our training. Just make sure you get trained in cloud before you go there, because you don't want to be standing up infrastructures that you fully don't understand and that you don't have a good sense for your attack surface. So yeah, it is a big problem with cloud.
Okay, so definitely good to get some more knowledge on attack surface management. Like you said, a big part of that is just reducing your attack surface where you can, where it's appropriate, right? Because sometimes you can and sometimes you can't.
Yep.
That's just the way it be.
I'll tell you, that's how I roll, Sophie, even with my own Mac. So the Mac has a somewhat reduced attack surface, but I will go into my Mac OS, and I encourage you to do that with Windows. And in your case, you'd work with IT to remember, a lot of times, get rid of those services you're not using. You can always put them back. And that's what I end up doing, right? I'll be like, oh, I'm getting rid of the DHCP functionality off this router completely. Oh, we're redesigning things and I need it. It can be put back.
Right. It's not a forever change. You can always go back and add things back. So that's good to know. So thank you for walking us through some of these principles of attack surface management.
My pleasure, Sophie.
And thank you for joining us for this episode. We'll see you next time.